Okay, so this is the warm up. It's printed on your paper, but to explain, yesterday we learned about the correlation coefficient. We learned what it means for something to be strong. Stop talking. We learned what it means for something to be strong versus weak and positive versus negative. Now we're going to relate it to the real world context. So we have a bunch of different scatter plots, and each row has some paired variables. And we're not talking like simply just X and Y. We're talking like these would be labels on an axis. Like this would be my X axis, temperature in Colorado. My Y axis would be labeled with this. So based on what's going on in the scatter plot, decide which one makes more sense, like which row goes with which scatter plot. Questions on what you're doing? Does that make sense? All right, I'll give you about 3 to 4 minutes to decide that. This is not like a group activity. So you are reading it, deciding which row goes with which scatter plot. So again, we're deciding, like using our life experience, which row of things that we're comparing to go with which scatter plot. So table 1, tell me one match that you were able to make. Okay, we're saying A goes with row 1. So if that is true, first of all, let's look at scatter plot A. Based on what we talked about yesterday, would you say that this is a strong or a weak relationship? It is strong because, everyone else listen, the more linear, the more it looks like a straight line, the stronger it is, the closer it would be to any line of fit that I draw. So then it's very predictable. Like if this is my X, this will be my Y. It's probably going to be a really good linear model. So yeah, it's very strong. So if this is going with row 1, that would mean that my X-axis would be the temperature in Colorado, which I'm abbreviating. And then my Y-axis would be boxes of cereal in stock in Miami. Okay, again, I'm abbreviating. Do you think that those two have a strong correlation to each other? So I probably shouldn't put that one. But do you guys see like what we mean? Oh, you meant to. Okay. So in that case, that would be different labels then. So let's see. That would be the average number of free throws shot in a season on the X-axis. And the Y-axis would be score of a basketball game. So do you guys think that, I mean, I guess maybe like at high school level, maybe. Do you think that in a basketball game, there's only 5, 6, 7, or 8 free throws thrown? Do you think that, and again, it could vary, like at high school basketball games, the scores are typically not like crazy, not in the hundreds, like we see on TV. So potentially, is there another one that might be better than this one? Which one do you think? Right? Okay. Yeah. Okay, so that would be measured student height in feet. And again, I'm abbreviating. And the measured student height in inches. Do you guys think that has a really strong positive relationship? That as one increases, so does the other? Yes, I would agree. I mean, really, like, I don't think you can have an outlier there. If you are 6 feet tall, 6 times 12 is, I don't know, but higher up on that list, so it would make sense. It would have a strong positive relationship. So yes, 3 does go with scatter plot A for sure. All right, table 2, what about another match you were able to make? B and number 2. So let's look at that one. Compared to the other scatter plots that are left, class, would you say that this is positive, negative, or no correlation? I would agree. I mean, it's not like super strong. It's not as strong as A, but if I were to draw a trend line, here's what it would look like on graph A. Like it would literally cover all my dots probably. This one drawn through the middle of my data where the points seem to be clustered around it, probably something like that. In C, it's hard to tell if it goes up or down, right? So in that one, I would probably say is my no correlation. The line would probably look like that, in the middle. The points seem to be clustered around it. And D, how would you describe that one? Positive, negative, or no correlation? For the most part, it looks like they're going down. I mean, not all of them, but for the most part, like you can kind of tell it's going down from left to right. So seeing B paired with number 2, that one says the average number of free throws shot in a season. And then the basketball team score. Does that one look good? Do they generally have a positive relationship? Like the more free throws that you throw, the higher your score is probably? Yeah. I mean, maybe not all the time. That's why it's not strongly correlated as like number 1 or A, I mean. But like for the most part, you would assume, because if the other team keeps like letting free throws happen, maybe that other team isn't that good. Who knows? But yeah, I would be comfortable making that pairing. So good. Table 3, tell me another pair you were able to make. All right, C going with number 4. So the one that has no relationship, you're saying that the X should be the minutes spent in a waiting room. Okay, maybe number 1. So we're changing our answer now that we're legal. Okay. Okay, that's fine. So now we're pairing it with number 1, which is my temperature in Colorado. And my boxes of cereal in stock at a grocery store in Miami. Do you guys agree like those don't really have a relationship? All right, none at all. Tomorrow we're doing a lesson on like causation, which is kind of paired with correlation, but not really. While you can probably say that there's a strong relationship, like maybe I do take some data. Are you listening? Maybe I do take some data and I see that it's like a strong positive relationship for these random variables. That doesn't mean that that is what caused it, right? Does a temperature somewhere cause boxes of cereal somewhere else to be like increased? No. So just because something might have a strong correlation doesn't mean that there's cause and effect there, which is something we're talking about. But clearly this one's no correlation, so it makes sense that it goes with number 1. So then by process of elimination, D goes with number 4. And that's the one that says the average number of minutes spent in waiting room. And the hospital satisfaction rating. Do you think that the longer you spend in the waiting room, the worse that they would rate the hospital? Yeah, and that's what's showing. As the X is increasing, as the time is increasing that you're waiting, the rating is decreasing. Okay, so yeah, that makes sense. And if you look at the y-axis, those numbers do make sense. Like I would probably rate it on a scale of 0 to 10, then 0 to 130, or 0 to 80. All right, good warm up. Any questions on this? I gotta make sure we're paying attention. Remember, this unit is more conceptual than calculation. So if you're missing all that information because you're playing games, working on other assignments, like I worry for you on this test. We're gonna do things a little bit out of order. We're gonna go to this activity next where it says correlation and zoo. But briefly, I'll tell you about the goal of today. I kind of mentioned it earlier. We're going to use the correlation coefficient to talk about the relationship between two variables. And when I say variables, I mean the two things being compared in the situation. So, I don't know, free throws and basketball score. We're comparing those things. So saying whether it's strong or weak, positive or negative, and using technology to find the correlation coefficient and explain what it tells me in everyday language. I'm recording right now. I know, like, for example, on sub days, you guys also have access to like my teacher notes, but I don't know about you, but I think it's way harder to learn from reading than from like a video. So please, like, while I know I can't really stop you from doing it, I know like some of those teacher notes still help someone out there, like genuinely, so I don't want to like have to hide them and wait till after school is over to publish them. But please, like, I can't stress enough, everything you would need to know, everything that could be better explained is in the video. And yeah, tomorrow, I can go right now. I do have a training, so I won't be here, like I'll be working, but I'm here, and you will have to do the last lesson on your own. Again, it's still me explaining it, and you should still listen to it. Genuinely, don't just copy the notes, because the notes really won't make a whole lot of sense without the explanation. And again, it's just causation, which if you need more explanation on that, you can always ask Thursday, but like the Friday that you're taking the test. So I need you to be on top of your own stuff and not just like copy notes when you could flirt with the person next to you, you know? So anyway, I will say that the sub left a good note about you guys. They did not leave a good note about like my 4th hour, and you guys had a quiz Friday. So my 4th hour, they said that would not stop talking during the quiz. So they all got zeros on the quiz. Like, know that I don't play around. I hate negative sub notes. You guys know, and I mean, they said you were perfect. I'm just warning you. You guys know the expectations. You know that the sub has pictures of all of you. They could say, so-and-so was terrible, blah, blah, blah. I usually tell coaches and parents. So please do not deviate from the task. Yeah, you can talk to your friend quietly. Don't be annoying, don't be distracted. Questions on that? Also, maybe bring headphones so that you can listen to the video at your own pace. But anyway, you have a practice in Schoology for every lesson. We have these assessments this week. So Thursday will be binder check and study guide day. Fridays will be the actual tests. We have a plan to retake the following week. So I mean, it's a weekend to prepare for that retake. But all the study guides are available. So no excuses. So yeah, make sure you have notes ready for Thursday. All right, you're gonna do this next activity. What you are gonna look at for each situation are the two things being compared, the two variables, and their R value. R value is another word for correlation coefficient. Based on what we talked about yesterday, tell me, do they have a strong relationship? Is it a positive or negative relationship? As one increases, what is the other one doing? Things like that. And then on your test, you will be ranking them from strongest relationship to weakest relationship. So we're going to do that as well too, just letting you know. Let's do the first one together. Again, this is on the back where it says correlation to. So we have the number of steps taken per day and number of kilometers walked per day. The R value is 0.92. So based on that R value and what you know about steps and like distance walked, raise your hand if you think that would be a strong relationship. Raise your hand if you think it'd be a weak relationship. Okay, this one is definitely strong. One, because common sense, the more steps you take, the like further distance you walk. And two, the R value is right there. It gives you a way to quantify how strong it is. So when the absolute value is close to 1, so I'll put absolute values closer to 1. Absolute values closer to 1 are strongest. And what I mean about absolute value, if you're not familiar, is how far something is from 0. So basically, ignore the fact that it's negative. What's the absolute value of 1? What's the absolute value of -1? So what I'm basically saying is ignore the fact that it's negative. That tells you something different. Is that absolute value close to 1 or close to 0? If it's closer to 1, then it's stronger. Okay, so strong. And then tell me, because it also says whether it has a positive or negative relationship. Would it go up or down on the graph based on the value? So raise your hand if you think for number 1 it would be positive. Raise your hand if you think it would be negative. Okay, strong positive is correct. So this is going to be positive because the number is positive. To me, that's easy. So they have a strong positive relationship or correlation that are basically the same thing. And if I were graphing it, it doesn't ask you to graph it, but if I was, since it is pretty strong, I'd expect it to be mostly in a straight line. And since it's positive, I'd expect it to go up from left to right. I wouldn't expect it to be a perfect straight line, because if it was perfect, it would be 1 exact. Make sense? Okay, so try that for the rest. You have 5 other ones. Should you finish early, start talking about which ones are strongest and which ones are weakest. We're going to range them. That's basically what you're doing with that. I'll give you about 4 minutes. You can work with your groups. Get about this one. Move forward to temperature of a rubber band and distance the rubber band can stretch. Would you say that's strong or weak? Strong. I mean, is it as strong as number 1's R value? No, but it's still closer to 1 than it is to 0, right? Okay, so strong. And table 5, positive or negative correlation? Definitely, because it's a positive number. That one's easy, I think. So if it were a graph, it wouldn't look as straight as number 1 because it's a little less. Maybe we get a little bit more distant. I don't know how you want to do it. But still going up from left to right, still relatively strong. And there's that. Questions? All right, table 6. For the car weight and distance traveled using a full tank of gas, and that R value is negative 0.86. Would that be strong or weak? Strong. Strong. And table 7, would that be positive or negative? Okay, great. So we have our first strong negative example. Now, if you said weak, make sure, like, understand what we mean. Absolute value of the number. So that's basically ignoring the fact that it is negative would that absolute value be close to 1? The absolute value of negative 0.86 is what? 0.86, that's pretty close to 1. So yeah, and that would go down from left to right, but be mostly linear. Table 8, what about the average fat intake per citizen of a country and average cancer rate of a country? That R value is 0.73. So table 8, can you tell me strong or weak? Strong. And if you were just choosing between strong or weak, I would definitely lean more towards strong on that one. Is it as strong as the ones before it? No, but it's still closer to 1 than it is to 0. So everyone keep paying attention. Once it gets close to 0.5 in any direction, it is harder to tell because that's like right in the middle. But I would say anything below 0.5 is definitely weak. Anything above could technically be strong, but be able to rank them if they're close, I guess, to do that in a section. And table 9, would that be positive or negative? Okay, great. So we're saying that based on a lot of data going in that direction, that as the fat intake increases, the cancer rate increases as well. All right, table 1. The score on science exam and number of words written on the essay question. Is that strong or weak? Weak. Because it's closer to 0 than it is to 1, so I would agree. Not as strong of a relationship at all. And table 2, positive or negative? Positive because why, class? It's a positive number. If it was negative, we just put a negative on there. All right. Well, we know now. There's a reason I assign reports. So table 3. Average time spent listening to music per day and average time spent watching TV per day. The R value is negative 0.78. Strong or weak? Weak. Because it's closer to, well, the absolute value is closer to 0 than it is to 1. And table 4, positive or negative? And I wrote the wrong number. I wrote the wrong phrase there. What do you guys think? And number 5, that was, oh, no, it's positive. I'm crazy. Okay, table 4. For number 6, is that positive or negative? So they are, if this one was graphed, it would go down from left to right, but it would not be very linear. Okay, so not a perfect straight line, but I should definitely be able to tell that it's going down rather than up. Questions? Okay, now here's what I need you to be able to do on your tests. If I have a bunch of R values to compare, be able to tell me which are the strongest, which are going to be better linear models, for example. So here's all the R values. We're going to rotate through the tables now. Go with the second tallest person at your table.
Oh, okay.
Camila, can you wait a second?
I think she's the tallest.
All right. So table 5. Out of the ones I highlighted, so the ones that you already decided are strong, weak, positive, negative, which one would be my strongest R value? Out of these highlighted options. Alright, so Camila, these are my options. So don't say you don't know if you have to guess. Out of these 6 options, which one would be considered the strongest? Alright, and that is true. Now, Camila, why? What is different about that number compared to all the others? What is it really close to? Guys, I'm not asking you to calculate anything. Not at all. How were we able to know, class, that all of these were strong or weak? If they were absolute value was closest to what? Okay, so what's the absolute value of 0.92? 0.92, absolute value means how far is it from 0? Would you say that 0.92 is pretty close to 1? So that out of all my other options is my strongest. Make sense? Yes? No? Yes. All right, table 6. Which one would be my next strongest out of all of these? You guys should take this down like on, you have a little bit of room on your margin. This is what's going to be on your test. It'll say which one would be the best linear model. You would say this one because it's closest to 1. Table 6, which one would be the next best? The one that has an R value of negative 0.86. You guys agree? Yeah. Because again, we don't care if it's positive or negative. We care is that absolute value close to 1. 0.86 is closer to 1. Table 7, what would be next? The 0.84. Table 8, what would be next? 0.73. Table 9, what would be next? 0.28. And there's only one left. Negative 0.17. So here's my strongest because the absolute value is closer to 1. Here is my weakest. So this one is the closest to 0 out of all of them. Questions, comments, concerns? Does that make sense? We don't care if it's positive or negative when we're talking about strength. All right, last thing I'm gonna have you do, so we're gonna go back to that activity we skipped. We're not gonna do all of it. But one thing I need you to practice now, which I've taught you how to do before, is to put this into Desmos. Use your graphing calculator or Desmos, whatever you prefer. Find your trend line, your line of best fit. And then I'm going to ask you some questions about what you see on your screen. So do that. Everyone try it. Everyone practice it. This is on the front of your paper. Act as if I don't know how to use it. I'm going to have you tell me what buttons to press. If I want to make a scatter plot and a line of best fit using technology, what would I do in Desmos? Hopefully you figured it out by now because you had time and people that you could ask and notes because we've done it before. So tell me like I'm in first grade. Tell me what to press. Okay, the plus sign where it says add item. And even if you didn't know, like hover around. There's only so many buttons you could press. So press this plus sign. And then what? Because in order to even use this, you need a table of values. So yeah. This, I cannot help you on your test. You would have to know to do this and what buttons to press and everything.
And remember, I taught you how to do it by hand too, how to estimate it, because sometimes you don't have a table of values. You can only do this method if you have a table of values. Stop, keep listening. Stop talking. Only look at the screen. Table 1. Shh. What I was gonna say is that if you mess up a data point, it'll change your answer slightly, but I still think it would be relatively close. Like if I messed up one of these data points, it probably wouldn't affect me that much unless I like really messed it up. Like if I made this 51 of 510, that would probably very mess up my data. So you just make sure it's what was given to you. And once you've put all your data in, you could take a look at this scatter plot that's here if you want. You could see without me even putting the line of best fit yet, I know it's pretty strong or weak and positive or negative. So there's probably a relationship between the distance in miles traveled and the travel time. So Priya's like looking at all her trips and comparing those things. How do I make it put the line of best fit? I heard someone say hit the wrench. How do I make it put a line on here? Did nobody put a line on their graph? Max it up. So we've done it once before. How do I put a line of best fit on here? Because this is great. I could see a picture of it, but if it asked me for like my slope and y-intercept, like how would I find that? What do I need to press? What do I need to type in? Not one person in here knows how to do it, even though I taught you and have videos and you take notes, nothing. Yes. Okay. Okay. Okay, so there's no more quizzes, so there's no more like opportunities to look at your notes for this unit. This you need to memorize. It looks like y equals mx plus b, except for that it's now y1, x1, so that it ties back to this table where you put x1s and y1s. See that? And then instead of the equals, because if I did put equals, there's nothing that pops up. But for some reason, it's this squiggly line, which means approximately. So that is what makes it think. You're only as smart as you're knowing how to use your calculator. Okay. I said that way wrong, but the calculator is only as smart as you are. You have to know how to make it think. And here's how you make it think by typing this in. Once you have that, look at all these great things. We mentioned some of them before. So when it says like, what does your slope and y-intercept mean? Well, here's the values for it. And we'll talk about what they mean in a second. Your slope is approximately 0.93. And your y-intercept is approximately 4.15. Okay, I get that from the M and the V. Look at all this other stuff that's here. On Friday, you learned about residuals. Whether you actually watch the video or not, I mean, you have a few questions on your test about it. So hopefully go back and watch it if you weren't making it. But residuals are your actual value minus your predicted value. The actual values come from your data, come from your scatter plot. Guys, look at the screen. Stop playing your little game. Stop doing your homework while I'm trying to teach you it. Okay. Actual data comes from the scatter plot itself. The predicted data comes from your linear model, comes from your line of best fit. So when I hit that button, if I were to type this all in, if I hit this little residuals plot button, you can see the residual plot around the x-axis. Because ideally, if you have a really good linear model, you'd want that actual minus predicted to equal 0. So like, look at what it did to the table too. For each x value, you have an actual y value and the predicted y value from the line. They don't have the predicted shown. But what they have here are the residuals. So like for the first one, it's off by about 2. For the second one, it's off by about 1.7, things like that. So pretty close. The more close your residual plot is to your x-axis, the better linear model you have. Because look what happens when I change some of the data. So for the most part, as one increased, so did the other. Fix it. Say that I decide to, instead of making that 72, say I make it 720. Look at what happened to my residual plot. Is it all around the x-axis anymore? No, it's now really far from it. Let me make it something a little more reasonable. Maybe let me make it 100. All right. So it's closer than what I last put in, but it's not as close as it was initially when they first gave it. So when you get that question on your test that says which residual plot shows the best linear model, you want it to be closer to the x-axis. All right. So that's just another thing you could look at with technology. The other thing to see here is the actual R value. If it ever has you calculate the R value, I think that was on a test 1 out of the 6 years I've been here. Here it is. Don't confuse it with R squared. We don't do that in this level of math. But the R value, your correlation coefficient for this, so let me change it back to my actual data, which is 72. My R value for this data is about 0.99. So would you say that that's strong? Very strong. So when we relate it back to the real world, and I know I didn't read you the situation, but Priya was looking at the distance she's traveled and how long it takes her. There's a really strong relationship between how far she has to go and how long it takes her, right? So when it says things like, what does the slope mean? Well, my slope being about 0.93. And what is slope usually? What over what? Rise over run. So if it's not over 1, put it over 1. Rise is typically your y's. Run is your x's. So whatever it's labeled as, that 0.93 is how much the time is changing by for every 1 mile that she has to drive. So rise over run, minutes over miles is how we're leaving that. That's how much changes by on average. Your y-intercept was about 4.15. By definition, your y-intercept is when what happens? What is true at the y-axis? What are all the x's at the y-axis? So your y-intercept, by definition, is when x equals 0. So look at what x was. It was her distance in miles. Look at what y was. It was her travel time in minutes. So we're saying that her minutes traveled is 4.15.
when she's gone 0 miles. So think about that. Why would that make sense? In your, I mean, not all of you drive, very few of you, but you could be at a stoplight. You're not traveling any distance, but you are stopped and you are traveling for some minutes. So that could be in relation to that. Maybe you stopped and got gas. Who knows? But for those 4.15 minutes of a minute, you are not traveling. Like, I guess moving, I should say. So that accounts for that. What it started with, the parts that we skipped, it says like what is a factor that influences travel time over car trips? So you could say traffic. Like she's still traveling, she isn't going any distance because she's stuck in traffic. You could say red light. You could say get gas. Like those are all factors that make this not a perfect linear relationship. There's some deviation. All right, and then like what factor has the most influence? Obviously the distance, but also things like, am I on a busy road or am I have open space? Like it just depends. All right, so that's what we mean by relating it back to the situation. Any questions on that? Okay, so make sure that your notes are complete, like for what we did today. I can check for that when we define your text. We have just one more lesson tomorrow. So otherwise you should have all your notes. If you don't, then we've got to